And I'd like to introduce Alexander Plavin, who's been in the Julia community for a while, doing lots of stuff. So take it away.
Yeah, hi everyone. Indeed, I've been using Julia for quite some time, but this is my first in-person JuliaCon, so I'm happy to be here. So today I will be giving this kind of lightning talk about the part I really like in Julia, that you can just use built-in collections, arrays, as tables and get all the features with just built-in types, effectively. So, there are really kind of two ways, two approaches to using tables and tabular data manipulation in Julia. One is the way that is most common, like the only way in Python and R, and I guess it's the most common in the world for that reason, is to use custom container types, like data frames and memory data sets. Maybe I missed something. But also in Julia, you can just use generic collections like vectors or abstract vectors of, in the base case, of named tuples. And I really mostly use tables in this matter, and this will be the focus on my talk. So in the context of this talk, kind of arrays as tables in Julia, there are kind of orthogonal choices. First of all, like what data structure you use, and there is a choice of like row-based, column-based, and kind of the either vectors or struct arrays, or maybe like some fancier data structures as well. And orthogonally to that, you can kind of choose from a wide variety of packages. And today I will highlight some like how tabular operations look in base Julia and what DataManipulation.jl brings. But of course, the ecosystem of packages that work with arrays is huge in Julia. So one of the reasons why I like this using built-in collections as tables is that they and their operations give you the familiar Julian performance model. So if you code this types table, it's extremely fast. You can even use it in tight loops. If you don't care about performance, you can use type unstable code and so on. So this is like what you have everywhere in Julia. So nice fit for tables as well. Also, it's of course composable. You can like choose your types and your functions independently, and everything works together. So just kind of mostly with base Julia and some CSV reading packages, you can create a table. Don't need any imports whatsoever. You can do so-called select, that is map, filtering, sorting, limiting, everything like this is already built into Julia. You don't even need any packages. So what is data manipulation then? So it is kind of inspired by split imply combine.jl. That package was pretty popular at some point. I contributed to it about 2 years ago. It's not really actively developed, and some things can be done cleaner and or more composably or modular way. So data manipulation is kind of, in my opinion, improving on that and getting more features in a kind of more consistent interface as well. So it has kind of two key parts to it. First is more convenient and simpler piping syntax that is for like everywhere in data manipulation. That is in datapipes.jl. I have a poster later today in the poster session. And also orthogonal to the syntax part, there is this functionality that is commonly used and commonly needed for tabular manipulation, but is not present in base Julia, like grouping, joining, some advanced maps, and so on. So this is just a glimpse of the poster. It will be in the poster session today on data pipes. And now let's move to, and just quick overview. Of course, I won't give you like a whole kind of complete description of everything that's available. Basically, like it has both traditionally tabular operations that work generally how you expect. They get kind of any collection in. It doesn't even have to be a table. It can be a collection of arbitrary objects. You can do grouping, joining. Joining is in flexi joins that I will also be giving a dedicated talk tomorrow. So this is one part. So kind of more general tabular operations that work with a wide variety of types. And the second part is kind of mostly small extensions to base functions that are also naturally occurring in many data manipulation workflows. So actually, I don't know if this is the bottom of the slides are visible. So it has, I think, to my knowledge, the most feature-rich lazy map in Julia. There is skip that is like skip missing, exactly like skip missing, but more general. You can like skip nams or whatever. There are some things like to work with nested data. Like you have this name tuple. Imagine it's your table row, and you can nest it. Everything is also like everything there is performant, compiled, like type stable and everything. So as I won't be giving a kind of like full description of what is available, I will just say a few words on the design principles. So I really, in the design of data manipulation .jl functions, I follow the example of base Julia because I like how it works with built-in collections. So the functions, they take arbitrary collections, not just vector of name tuples. It can be your like favorite abstract array of your favorite structs. It can even be a tuple. This is can be convenient in tight loops if you have a lot of small tables or you have like a single small table and you want to run like optimizer many times. If you have like 10, 20 rows, it can be faster to just have a tuple. There is a heavy use of lambda functions for flexibility. Instead of specifying like a column name, you can provide arbitrary function. Same as you have in base and map. It takes a function in the collection or a table. Same approach is, for example, in group. And as I said, the familiar performance model, write type stable code for performance, it will be fast everywhere. Or write type unstable lambdas if you don't care much about performance, if your data set are smaller. Of course, there's always these caveats. Type stability is not 100% obvious in Julia. There are often these like Slack threads or discourse threads discussing it. But this is kind of, again, what you get everywhere in Julia. To sum up, really kind of in Julia, what I like with working with like tabular and quasi-tabular data, that a lot of operations are possible, convenient, without any custom types. Like in Python, you cannot really do that with built-in lists or NumPy arrays. No, it's not very convenient. Base is already enough for many basic table transformation. DataManipulation.jl is a package that provides even more tools for that. And the key thing here is that you write your code using some functions. And they work on row-based, column-based arrays you can choose afterwards. They work on tuples for small tables. And actually, most of the code is compatible with SQL, with MySQL collection.jl package. You can use map filter and group that will work exactly the same on SQL tables without materializing everything, and as it works on in-memory datasets. So yeah, that's it from my side. Thank you for your attention.
Yeah, I think we probably have time for quick one question. And next speaker, please come to the front for the setup. Any questions?
So with data frames, as I understand it, those are actually abstractly typed on purpose. Can you talk about like maybe some of the trade-offs there between having something like concretely typed and like what you lose when you're going towards that?
What you lose when you go into abstract type corrections like data frames is that you lose this kind of like familiar performance model. So first of all, kind of they are heavily focused on flat tables. If you want like kind of some nested structs, it is kind of a whole kind of words how to work with it. They have to be careful like not to just pass the lambdas, but like pass more. They take more structured kind of inputs. And also, if you have data frame syntax, it only works with data frames. If you have basic collection syntax, you can choose whatever type you want. Yeah. But it's kind of course a huge topic.
Yeah. Thank you, Alexander. And I'm happy to introduce Lilith Hafner, who's well known among the people who are trying to make sure that Julia keeps moving forward in the triage group, like really keeps that going. So take it away.
Okay, let's see.